Today we're doing section 5.5 and we are going to be solving trigonometric equations. So this section is going to be very different than the rest of chapter 5 and where we've been verifying. So now we're actually solving. So for our first example, we have 3 sine of x minus 2, and that's equal to 5 sine of x minus 1. And the directions say solve and find all possible solutions. So in order for us to solve this problem, we need to essentially get all of our x terms on one side and anything that doesn't have an x on the other side. So I'm just going to rewrite this down here. So I'm going to subtract this 3 sine of x over, just so that I'm keeping my sign positive. And that means I'm going to be adding this 1 over. So I'm doing two things at once. I'm canceling out these signs and I'm canceling out these 1s. So by doing that, I get negative 1 is equal to 2 sine of x. Then to get sine by itself, I would divide both sides by 2. So sine of x is equal to negative 1/2. And now this is where kind of the inverse concept comes into play. I need to figure out what is my value for x such that I would get an answer of negative 1/2. So first thing we need to recall is that sine represents y. And if I think about my coordinates, I need to envision this negative 1/2 being in the y spot of the coordinate, which means this x part has to be root 3 over 2. So I know I'm definitely dealing with some kind of coordinate that has a 6 for the denominator. Next thing I need to take into consideration is my quadrant that I'm in. So if sine is negative, we remember this whole thing. So we know sine is positive in quadrant 1 and 2, so sine is negative in quadrants 3 and 4. So that means my denominator is definitely a 6, and the quadrant that we're in is 3 and 4. So that means I'm dealing with a 7 pi over 6, because that's right past this pi mark right here, and 11 pi over 6, because that's right here less than 12 pi over 6, which is 2 pi. Now, the way we write our final answer is, I'm going to actually go to the next screen, is x equals 7 pi over 6 plus 2n pi. And then we write x equals 11 pi over 6, also, again, plus 2n pi. So the reason we put this 2n pi is that the whole idea of coterminal angles, if I want one more revolution around, so if I circulated around one more time, again I would get the y value of negative 1/2, it would just be one angle larger. So for example, if we said n is 1, I would have 7 pi over 6 plus 2 times 1 times pi, which is essentially 2 pi. And if I wanted to get common denominators, I would multiply by 6. So 7 pi over 6 plus a 12 pi over 6. So the next possible answer I could write is 19 pi over 6. Well, the only thing is I don't want to sit here and write every single possible answer, so that's why we express it as plus 2n pi, because that implies that I could just keep going and going and going where n is any given integer. So that is our first example for today. Now we're going to do a second example where the directions do not say list all possible. I'm looking for a specific set of answers. Okay, So the directions, or the problem says sine of x over 2 is equal to root 3 over 2. Let me rewrite that. Root 3 over 2. Now the difference here is there is a restriction. The restriction is my x value has to be greater than or equal to 0, but less than 2 pi. So now I'm looking for a specific set of answers, not every possible answer. This problem is slightly different in the fact that I don't need to do any solving or moving terms from side to side. I just need to figure out what angle would give me an answer of root 3 over 2. So I know, again, that sine is the y value. So if I envisioned a coordinate, I would put that root 3 over 2 in the y spot, which means the x spot has to be a half. So I'm definitely dealing with a denominator of 3. And notice I have a positive root 3 over 2. So I'm dealing with quadrants 1 and 2, because that's where sine is positive. So the two angles that I am going to be using is pi over 3. So I can say x over 2 has to equal pi over 3. Or I have to say x over 2 equals 2 pi over 3, because those are the two values that come from quadrants 1 and 2 that have a denominator of 3. So just like the last problem, we add on this plus 2n pi. Oh, that didn't come out. So 2n pi for both of these. Now I'm actually going to have to do some work and solve for x. So in the last problem, it's just x was already by itself. There was nothing located within the trig function. Now there is. So to get x by itself, I have to multiply everything by 2. So I'm going to multiply everything by 2 to clear this fraction. And same thing down here. We'll just do both equations at the same time. So this top equation becomes x equals 2 pi over 3 plus 4n pi. So there's one answer. And then x equals 4 pi over 3 plus 4n pi. And here's our second answer. Now, we are not done. Now we need to check possible scenarios, because remember, my only answers for x have to be within 0 and 2 pi. So I'm going to take these two problems and switch it to the next screen so that I can do the second part of the problem. So if I have x equals 2 pi over 3 plus a 4n pi, and I had this x equals 4 pi over 3 plus 4n pi. So first scenario we are going to check is n equals 1, or sorry, n equals 0. And we're going to check it for both scenarios. So if n equals 0, now I plug a 0 in for this n right here. So this 4 times 0 times pi. That whole thing's going to cancel out and become 0. So I would just get the answer of 2 pi over 3. Similarly, over here, I would just get the answer of 4 pi over 3, because when I plug in a 0 here, 4 times 0 times pi would just give me 0, so it would cancel out. So when n equals 0, here are two answers, and they are definitely within the restriction. So now I need to check n equals 1. So I have 2 pi over 3 plus 4 times 1 times pi. So that means I'm dealing with a 4 pi. So I'm just going to rewrite this as 4 pi. And now I need to get common denominators. So I would multiply this top and bottom by 3. So I have 2 pi over 3 plus 12 pi over 3. So when I add these together, I get 14 pi over 3. However, the restriction in the problem stated that my x value had to be greater than 0 but less than 2 pi. And if I were to get common denominators with this and multiply top and bottom by 3, essentially this is saying 0 is less than or equal to x less than or equal or less than 6 pi over 3. So when I plug in 1, notice this 14 pi over 3 is too large for this problem. So I don't need to even check the other scenario, because if this one was too big, then the next one definitely will be too big. So at this point, I can concur that there is only 2 answers into this problem, and that is it. So that's all for today. We'll pick up with this tomorrow.